Welcome to the listening section of the TOEFL mock test, brought to you by Spinta. This section measures your ability to understand conversations and lectures in English. In this section, you will listen to several conversations and academic lectures. Each conversation and lecture is followed by a number of questions. You will hear each conversation or lecture only one time. You may take notes while you listen. You may use your notes to help you answer the questions. Some of the questions will replay part of the audio for you. Answer the questions based on what is stated or implied by the speakers. You must answer each question before moving on. You cannot return to previous questions in this section.
Good morning, everyone. Today, we will look at urban green infrastructure and the concept of ecosystem services as a framework for designing cities that are resilient, healthy, and more equitable. When I say green infrastructure, I mean elements like street trees, green roofs, bioswales, permeable pavements, and urban wetlands. These are intentional, managed parts of the urban fabric that provide ecological functions. Ecosystem services is a term that helps us categorize the benefits people obtain from ecosystems. The common categories are provisioning services, regulating services, supporting services, and cultural services. This classification is useful because it makes the benefits visible in planning conversations. Regulating services are especially relevant in cities. For example, vegetation reduces stormwater runoff through interception and infiltration, and it lowers air temperature through evapotranspiration and increased albedo. These processes reduce peak flows in sewer systems and cool neighborhoods during heat waves. Let me give you a quantitative example. Extensive green roofs can retain between 50 and 70% of annual rainfall, depending on substrate depth and plant cover. That retained water does not enter the stormwater system, which can reduce combined sewer overflows in older cities. Bioswales and permeable pavement perform similarly by increasing infiltration and slowing runoff. They also filter pollutants, which is a regulating service that improves water quality. Supporting services refer to processes like nutrient cycling and soil formation. These are less obvious to the public, but they underpin other services. If soils and urban green spaces are compacted or contaminated, the vegetation will not deliver the regulating or provisioning benefits we expect. Cultural services include recreational opportunities, mental health benefits, and aesthetic value. A well-designed park increases property values and can create social spaces that strengthen community ties. Of course, integrating green infrastructure involves trade-offs. There are upfront costs for installation and ongoing costs for maintenance. There can also be spatial trade-offs when street space is limited. However, these costs need to be compared with avoided costs, such as reduced energy use, lower stormwater treatment expenses, and fewer heat-related health incidents. A useful way to think about this is cost-benefit analysis that incorporates ecosystem services. By assigning monetary values, or at least comparable metrics to services like flood reduction and cooling, planners can make more informed choices. I want to highlight a real-world case study. Philadelphia implemented a green stormwater infrastructure program that included green roofs, tree trenches, and pervious pavements. Over a decade, that program reduced combined sewer overflows and delayed the need for some expensive gray infrastructure upgrades. This did not happen overnight. Philadelphia combined pilot projects with monitoring, adaptive management, and community engagement. The monitoring quantified reductions in runoff and improvements in local water quality, which justified further investment. Another interesting example is Singapore, where policy integrated urban greening into development codes. There, the challenge was space and high land values. The solution included vertical greening and incentives for developers to include green roofs and facade vegetation. Biodiversity is also essential. When we plant a limited palette of ornamental species, we get superficial green cover, but limited ecological function. Diverse native plantings support pollinators, improve pest control, and increase resilience to pests and extreme events. Ecosystem services are not just ecological concepts. They are practical tools for urban planners to compare costs and benefits. That is why I emphasize monitoring and valuation in every project proposal I review. In conclusion, green infrastructure offers multiple co-benefits, from stormwater management and cooling to biodiversity and social well-being. The challenge for practitioners is to design with rigorous ecological knowledge, quantify benefits where possible, and balance short-term costs with long-term gains. Next week, we will examine tools for quantifying ecosystem services and practice a simple valuation exercise. For now, please reflect on the examples I mentioned and consider what trade-offs would matter most in your own cities.
Listen again to part of the lecture, then answer the question.
Ecosystem services are not just ecological concepts. They are practical tools for urban planners to compare costs and benefits.
For more TOEFL mock tests as well as IELTS and Cambridge practice, visit www.spinta.org. We provide updated tests every single day, AI feedback for your speaking and writing responses, and access to a wide range of high-quality mock tests to help you prepare with confidence.